Sorry about that, the computer is cut off again. So we said yes that the graph of g of x exists at negative infinity. Not so. So where does this graph stop existing at? 4. Can you see that? Remember, range of all possible y values. So the graph exists at, will stop existing at 4. So in other words, we have y and a 4. But y must be less than. Does the graph exist at 4? Yes. So it has an equal sign there. So y is less than or equal to 4. Okay. Look at 8.6. In 8.6, for which value of values of x is the function f of x and g of x both increasing. So we're now going to look at the graph where both parts of the graph is increasing. So if you look at this part of the graph, okay, let's look at f first. What do you notice about f? It's always increasing, not so. So in other words, we are only going to say where the graph of g is increasing, because like f is increasing all the time. So the graph is g increasing or decreasing here? Increasing. Remember, I'm moving from left to right, and on the side is decreasing. Can you see that? So in other words, x must be less than 1. Okay? You can't say equal to 1, you just say less than 1. Because at 1, the graph is neither increasing nor decreasing. Okay? It's 8.5. Cut. 8.7. 8.8. So here we are told explain why the inverse of g of x is not a function. Just take this green out here. We must explain why the inverse of g, which is the parabola, is not a function. So why is that not a function? It does not pass the vertical line test. That's your answer. And what type of relation is that? 1 to many. Okay? Let's look at 8.8. Write down 2 ways in which the domain of G could be restricted so that the inverse can be a function. How can that be restricted? X is less than or equal to 1 or greater than or equal to 1. Okay? So if I take this part into account only, and I reflect that in the line y is equal to x. Okay, and reflect that in the line y is equal to x. It's going to become 4 and 1, the turning point. 4 and 1. It's actually the other way around, no? Because it look like that. 4 and 1 becomes, no, it's the first one was 4 and 1 becomes, we solve that around, become 1 and 4 becomes 4 and 1. So that's what the graph is. That one arm. Can you see that? So is that then a function? Yes. Why? Because that passes the vertical line. But if you had put the other part of the graph here, remember that is now 4 and 1. And it's not a good representation, but that's basically what's happening. This point here is that point. That one there is of course this one. In account. Not so. So as it stands here, this is your inverse. Okay? And it's not a function y, so it does not pass the vertical line. However, if you had taken the part where x is less than or equal to 1, which is that part of the graph, so is that a function? Does that pass the vertical line? Yes. Because we're at any given point, that's going through this graph at one point only. So yes, that inverse will then be a function if x is less than or equal to 1. If x is more than or equal to 1, of course it's going to be the other one. This is actually the representation of this part of the graph. So where x is greater than or equal to 1 is this arm. The other one is going to be the one that I took out earlier. Can you see that, people? How do I know that? Because I have this little, what's the name there? That would be this value in question. Okay? This is very important to know. Normally counts with 2 marks. Okay? I think that's the end of this section. Is that correct? Yeah. So now we're going to do something else. Let's just stop the video at this point. Where are we now? Oh, this lower. Take this out. And that basically concludes exponential and log functions. Okay.